Okay, today we are going to begin chapter 7, which is on angles and angle measurements and angle relationships. It is the beginning of our geometry unit, or chapters 7 and chapter 8. The first lesson of chapter 7 starts on page 535 and is about angles and angle relationships. So an angle is formed by two rays that share a common endpoint called the vertex. The vertex is that point where the two rays meet. Complete the table by drawing the hands of a clock to represent each angle. So what I would like for you to do in your notebook is to go ahead and draw a 90-degree angle, an acute angle, an obtuse angle, and a straight angle. Remember, a right angle is exactly 90 degrees. So what you want to do is make like a square in. So 3 o'clock would be an example of what a right angle would be. And oftentimes it is marked with a box. What about an acute angle, which is less than 90 degrees? Well, you could make a number of acute angles in here. I'm just going to draw mine between 12 and 2 o'clock so that it is less than that 90-degree angle. An obtuse angle is greater than 90 degrees. So I'm going to draw from 12, and then I'm going to go down to 5. And that's going to create an obtuse angle. And then a straight angle would be exactly 180 degrees. So I'm just going to draw a line as straight as I can down from 12 to 6 to represent a straight angle. So when we go down here to the bottom where it says real world link, it says the angle formed by the bike ramp shown. What is that type of angle? That is an acute angle because it is less than 90 degrees. So we're going to put in acute here. I'm going to have to move this up. Estimate the measure of that angle. Well, since it is less than 90 degrees, we could take a look at it and go, okay, is it more or less than half of a 90-degree angle? Because half of a 90-degree angle would be 45 degrees. It appears that it is well less than half. If I draw this so that there is a 90-degree angle in there, you can kind of see that this is probably, I don't know, maybe even close to 65 degrees, maybe even 70 degrees. So I would say that this is probably about, I would say somewhere between 20 and 30 degrees. It says name and identify angles. Two angles are vertical if they are opposite angles formed by the intersection of two lines. Vertical angles are congruent or have the same measurement. So congruent is geometry speak for equal. They are equal in size and shape. So if you look up here, vertical angles are formed by intersecting lines. And what they are, I call them kissing angles. The reason I call them kissing angles is because they only meet at one point. So it's like the two angles are kissing each other. So if you look at angle 1 and angle 3 here, angle 1 and angle 3 are meeting together at this one point. That makes those two angles vertical. So angle 1 and angle 3 are also congruent because they are vertical angles. See this symbol here? It's an equal sign with a little squiggly above it. That's how we show congruent. So you can also see that angle 2 is congruent to angle 4. That's because that is another pair of vertical angles. See how angle 2 and angle 4 are straight across from each other. They're kissing each other, and they are the same size and shape. So they are vertical angles, and therefore they are congruent. Adjacent angles are different. Adjacent angles not only share an endpoint, but they also share a common side. So if I were to trace across this right here, angle 1 and angle 2 both share that ray. They both share that segment of the line. So therefore, those two angles are adjacent because they are touching each other. We don't have any rules about the measurements of adjacent angles. Adjacent angles could be equal. Adjacent angles could be not equal. So therefore, there are no rules for adjacent angles. But because angle 1 and angle 2 are touching each other, they are adjacent. What about angles 2 and angle 3? They share a side. So angle 2 is also adjacent to angle 3. Angle 2 is adjacent to angle 1. Angle 2 is adjacent to angle 3. But angle 1 and angle 3 are not adjacent to each other. They don't share a side. In fact, angle 1 and angle 3 are vertical angles. Angle 3 and angle 4 are adjacent because angle 3 and angle 4 share this side. And then angle 4 and angle 1 are adjacent because they share that side. So, adjacent angles share a side. Vertical angles only share an endpoint. They're kissing angles and they're right across from each other when formed by two intersecting lines. It says you can name an angle by its vertex and its points. So this is still page 536. And example 1 says, name the angle shown at the right, then classify it as acute, right, obtuse, or straight. Well, first, there are multiple ways to name an angle. I can call this angle 1. And the reason I can call this angle 1 is because they put a number inside of that angle. That allows me to use that number to name it. I can also call this angle Y. Because Y is not on any other angle, it is only on this angle, and it identifies the endpoint of it. So this angle is standing alone. I can call this angle Y. But the most common way that you're going to see angles named when they're inside of shapes is by 3 points. You can call this angle X, Y, Z, or you can call it angle Z, Y, X. If you notice, the Y is in the center of both of these two names. That's because you must put the vertex letter in the center. So that should allow you to be able to, what kind of angle is this? Well, it's less than 90-degree angle, so therefore it is an acute angle. That should prepare you to do letters A, B, C down here at the bottom. Make sure that you are naming the angles, all the ways that you can name it, and then tell whether it's an acute, right, obtuse, or straight angle. Let's go on to example number 2. It says, identify a pair of vertical angles and adjacent angles in the diagram at the right. Justify your response. So, take a look here. Angle 1 and angle 2. Those two angles touch along Garfield Road. So angle 1 and angle 2 would be adjacent angles. So my adjacent angles are angle 1 and angle 2. Notice angle 2 and angle 3 touch each other. So angle 2 and angle 3 are also adjacent angles. Angle 3 and angle 4 touch each other. So angle 3 and angle 4 are adjacent angles. And then angle 1 and angle 4 touch each other. So angle 1 and angle 4 are adjacent angles. What about vertical angles? Some vertical angles would be angles that just kiss and are across from each other. So these two angles are straight across from each other and are kissing. So that would be angles 1 and angle 3. And in addition to them being vertical angles, I can also say that they are congruent. So I like to list my congruent or my vertical angles that way, with that congruent symbol, the equal sign with the squiggly over it. Angle 4 and angle 2 are also meeting at one endpoint and are kissing each other, and they're straight across from each other. So angle 2 is also congruent to angle 4, and so they are vertical angles as well. So you do not have to do that one. I just did it for you. Now, here we get to the real meat of this lesson, and that is using vertical angles and adjacent angle relationships to do some math. If you take a look at this diagram, and I've highlighted some things and I've marked some things on here, you can see that there are two sets of vertical angles. These blue angles are vertical to each other, and the yellow angles are vertical to each other. Since those angles are vertically to each other, they are also congruent. So in this problem, it says, what is the value of x in the figure? The angle labeled 2x plus 2 degrees and the angle labeled 130 degrees are vertical angles. So we're looking at the two yellow angles. Since they are vertical, I can actually write an equation that says they are equal. So I can write 2x plus 2 is equal to 130 because my two angles, 2x plus 2 degrees and 130 degrees, are a pair of vertical angles. They have to be congruent. They have to be the same size. Now we have a two-step equation that we just need to solve. How do we get x by itself? Well, if you think back to November and December, you know we need to subtract 2 from both sides first. We're going to use SAD-MeP, the reverse order of operations, to solve. So we're going to do addition and subtraction first. When I subtract 2 from both sides, I'm left with 2x equals 128. And then I would divide by 2 on both sides. And so x will be by itself, and 128 divided by 2 is 64. So x is going to be 64. You need to now do letter E, which asks you to determine what is the value of y in example 2. So in order to do that, you need to look at the two blue angles, which are also a pair of vertical angles, which means those two angles are congruent. So you are also going to write an equation, hint, hint, and solve it. Example 4 says, what is the value of x shown in the sidewalk? Well, if you look at these two angles, you have one 115 degree angle, and then you have one that says 5x degrees. Those two angles are not vertical. So we cannot do the same thing that we did on the previous example or on letter D or letter E. Instead, we've got to look at these two angles and go, okay, those two angles are adjacent because they're touching each other along this line. But also, if you look at the long blue line that I just drew in there, together they form a straight line. We know that straight angles measure 180 degrees. So these two adjacent angles, if I put them together, have to make this straight line. So I can actually say 5x plus 115, when I add those two angles together, will equal 180 degrees. Now I have an equation that I can solve. I will subtract 115 degrees from both sides of the equation. Remember, using SAD-MeP, we do addition and subtraction first. And so I subtract that away. I'm left with 5x on the left is equal to 180 minus 115, which is equal to 65. Then I will divide by 5 on both sides. And when I do that, x equals 13. So I'm able to get what x is by knowing that those two adjacent angles form that straight angle. So I can just add them together and make them equal to 180 degrees. That takes us up to the guided practice.